Okay, let's dive right into this. $2.6 billion, or if you're looking at the Japanese market, a staggering 400 billion yen. That is the explosive valuation Sakana AI hit after their massive Series B funding round in late 2025. Now, this isn't just another routine capital raise, right? We are looking at a lab that's fundamentally rewriting the rules of AI. They're changing how it reasons, and honestly, how it's deployed in some of the most high-stakes environments on the planet. The sheer financial stakes we're talking about here, they directly reflect the absolutely wild technological breakthroughs happening behind closed doors.
So today, in this explainer, we're tracking a journey. We're going from deep, theoretical computer science straight into the real world. Sakana AI is rapidly evolving from a celebrated research lab into a multi-billion-dollar enterprise powerhouse. They are actually taking these theoretical models that mimic natural evolution, and dropping them into strict zero-failure environments like megabanks and national defense. It's a massive shift. Here's our roadmap for the explainer. We'll hit the sovereign AI unicorn, fusing LLMs with diffusion, automating scientific discovery, and finally, the news software engineer. Let's just jump straight in.
Part 1. The Sovereign AI Unicorn.
So how exactly does a startup hit a $2.6 billion valuation that incredibly fast? Just look at the sheer velocity of this timeline. In early 2024, they grab a $30 million seed raise. A really healthy start for an ambitious lab. Then, by August 2024, they completely shake the academic world by publishing The AI Scientist, which we're going to dig into in a minute. But then, fast forward to late 2025. Boom, they close a $135 million Series B round, rocketing them to unicorn status. But listen, the cash itself isn't even the most vital part of that milestone. It's who they're partnering with. They locked in a massive multi-year partnership with MUFG, Japan's largest banking group. This is a definitive pivot. They aren't just building cool research demos anymore, they are building critical enterprise-grade infrastructure. The secret sauce here is their strategy of deploying sovereign AI. Sakana realized, hey, trying to compete head-to-head with the big tech giants strictly on computing power, that's just not the smartest path. Instead, they hyper-focused on data security and localization. Think about it. For partners like a massive bank, AI simply cannot live on a public cloud. The data is way too sensitive. So Sakana's engineers actually build and deploy AI agents directly inside the client's localized domestic infrastructure. Highly sensitive banking data literally never leaves the country. And this incredibly secure lockdown approach, it earned them serious attention in the defense sector too. They won awards from Japan's ATLA and the US Defense Innovation Unit for things like biodefense and disinformation countermeasures. They're essentially crafting AI that's culturally optimized for Japan while passing the absolutely strictest security tests in the banking and defense worlds. But here's the catch. To operate in environments where you literally cannot fail, your AI needs a totally new level of reliability. Which brings us to part 2, fusing LLMs with diffusion. To meet the demands of a mega bank, an AI can't just play a guessing game with the next word. It needs to genuinely reason. And this comparison right here, this is the heart of their technical leap. Traditional language models are single-step autoregressive. That basically means they generate text in a straight line, one token at a time. Sure, it's blazing fast, but there's a major flaw. If the model makes a tiny mistake early on, it compounds that error and it doesn't have the ability to go back and fix it. It's kind of like someone speaking before they've thought their sentence through. Sakana's fix for this is called L2D, which stands for LLM to diffusion. They take a standard language model and fuse it with multi-step diffusion, which is actually the same underlying math used in AI image generators. So instead of locking in a word instantly, the model starts with this noisy, fuzzy concept of the answer and iteratively refines it over multiple steps before finalizing what it spits out. So what do we mean by diffusion fine-tuning? Well, by definition, it's empowering pre-trained language models to adaptively scale computation through iterative denoising steps, granting them self-correction capabilities. Okay, let's translate that into plain English. You are basically giving the AI more time to think while taking the test. With traditional AI, all the heavy computational lifting happens months ago during training. But with L2D, if a problem is super difficult, like say a complex banking algorithm or a nasty math equation, the system can dynamically decide, hey, I need to spend more compute time refining this answer before I show it to the user. It literally self-corrects its logic mid-thought. It's a total game changer.
And the data completely backs this up. If you look at the baseline performance of a standard language model compared to the blue bars representing Sakana's L2D model, the trend is undeniable. As you increase the L2D inference steps, the average score on complex benchmarks just keeps going up. It monotonically increases. Put simply, more time to think directly equals a smarter, more accurate AI. And that is exactly the kind of verifiable reliability you need before you hand over the core operations of a major financial institution to an AI agent.
All right, let's look at part 3, automating scientific discovery.
So, if an AI can literally iteratively reason its way through complex code, what happens when you point that exact same tech at the scientific method itself? Well, you get the AI scientist V2. And honestly, this is arguably one of the most stunning milestones in recent tech history. Sakana AI built a system that independently generated a research paper that successfully passed blind human peer review at a major AI conference, ICLR, and it was even highlighted in Nature. No way, right? It didn't just write the text. It generated the initial idea, wrote the actual code, ran the experiments, plotted the graphs, and formatted the final academic paper. A 100% automated research pipeline.
How in the world does it actually do this? The V2 open source release uses something called agentic tree search. Instead of just walking down one linear path, the AI explores a massive tree of possibilities. It comes up with an idea, and if an experiment fails, no problem. It just prunes that branch and searches down a totally different algorithmic pathway. It runs these experiments in parallel, wildly accelerating the trial and error phase. And get this? This is incredibly cool. It uses a visual language model to actually look at the charts it creates. It evaluates them visually to make sure they're legible and properly communicate the data exactly like a human researcher would. It's a systematic, autonomous explorer of complex hypotheses. Finally, part 4, the new software engineer. So look, if AI is out here writing its own code and testing its own hypotheses, what does that mean for us, for the humans? Mizuki Sango, a software engineer over at Sakana, puts it perfectly. She says using AI agents is like having 4 to 5 junior engineers that you're managing. And hey, anyone who has ever managed junior devs knows that is both an absolute superpower and a whole lot to handle. This is a massive paradigm shift. She doesn't just write code anymore, she orchestrates it. She describes her workflow as using Claude Code as the main hub, assigning Gemini to do deep web research, and having ChatGPT handle large-scale system architecture refactoring. She's managing a team of distinct AI personalities, using their unique strengths to cover her own blind spots. The engineer isn't a typist anymore, they're a conductor. Her colleague, Ryunosuke Iwai, who's actually a former competitive programming champion, frames the stakes even higher. He says this is equal to or greater than the invention of the internet. If you work as an engineer, you have to do AI. He points out that the whole era of simply writing code manually, that's ending. Because AI models operate probabilistically, meaning they sometimes fail, hallucinate, or time out. The human's real job now is to build hyper-resilient systems that gracefully handle those probabilistic errors. The fundamental core value of the human engineer is shifting right before our eyes. EY actually breaks down the future role of the systems engineer into 3 distinct, really actionable steps. First up, creating the environment for AI. You've got to build the sandbox. That means connecting the data pipelines, allocating the compute resources, and giving the AI the tools it needs to just swim freely. Second, co-ideation. This is humans and AI bouncing ideas off each other. The AI is doing the heavy implementation for sure, but the creative spark, that remains a total collaborative effort. And third, and honestly, this is absolutely crucial, evaluation. You must set the direction. The human has to define the optimization score. What exactly are we even trying to achieve here? Setting that true north for these wildly powerful systems is a responsibility that we absolutely cannot hand over to the machine. Which leaves us with this final thoughts. We've seen how Sakana AI is evolving from these amazing nature-inspired theories to securing billions of dollars, all to deploy self-correcting, researching AI agents right into the heart of global finance and defense. The tech is rapidly moving from single-step guessing to deep, multi-step reasoning. As AI effectively masters the syntax of code and the deep rigors of the scientific method, the bottleneck is simply no longer human typing speed. The new bottleneck is human management and human vision. So as these systems scale, the ultimate question for literally anyone in the tech industry today is this. As AI learns to write its own code and conduct its own research, are you ready to become a manager of machines? Thank you so much for joining me for this explainer. Keep learning, keep adapting, and I'll catch you next time.